Welcome to more trigonometry fun. Tonight's video is going to look at a missing angle. Sometimes that angle will be referred to as theta, and you can see theta here in this diagram. So that is our missing angle. We're on this page in your notes. The introduction says that trigonometric ratios can also be used to find missing angles in a right triangle if two sides have been given. So the example states we have right triangle ABC, where C is the right angle. We have two legs BC and AC measuring 15 and 20. Find angle A to the nearest degree. So we've put an X there, and when we look at the triangle, we focus on the angle and the sides we have been given. This is my missing angle, and these are the two sides. So in this case, I do not have the hypotenuse to work with, so I will be using tangent. And remember, the tangent ratio is opposite over adjacent. I'm going to leave my missing information missing, and I'll set up my ratio tangent of A equals 15 over 20. Now that is something that you can do by mental math, so we know it's 0.75. And what this is saying is I need an angle whose tangent is 0.75. To find this on our calculator, it is the inverse tangent key, also known as arctangent. So on your calculator, you are going to have to use the second function key, which is up at the top left. It could be blue, it could be yellow. If you have a pink calculator, it might be orange, I don't know. And then you hit your respective trigonometry function. So because I'm using tangent in this case, I will hit second function, tangent, and I can put in 15 over 20 or I can put in 0.75. Either will work. So I would like you to try that, and hopefully you will get the answer shown, which is rounded to 37 degrees. Let's look at a few more examples. In right triangle DEF, E is the right angle, DE is 8 yards, EF 8 yards also. How many degrees is angle D? Hopefully right now you know the answer to that, but that's okay. Let's solve it anyway using our inverse trig functions. So draw a picture as if you didn't know what this angle was, and label it, as drawing the picture is the key to most of these problems. So I know my right angle is at E. I have D, E is 8, and EF is also 8, and now I can set up my trig ratio. Again, if I am looking for angle D is here, and I do not have the hypotenuse, so I must use tangent. So I'll set that up. Tangent of D equals 8 over 8. So try this in your calculator. I want the angle whose tangent is 8 over 8, or I want the angle whose tangent is 1. And when you plug that in, you should get, I might do 8 over 8, then it should come out with plain and simple 45 degrees, which we knew to be true. Let's try one that we cannot do using mental math. Question 2, the old ladder problem, right? So again, pictures are really key here. We want to be able to draw an accurate picture to help us with the problem. The ladder is leaning. Here's my typical ladder leaning against the building, and it's 25 feet long. It reaches a point above the ground 23.5 feet. I want to know to the nearest degree the angle makes with the ground. Always good to go back and look at what they want you to round to, because typically trigonometry problems will not work out to a whole number. So the ladder makes with the ground. Well, here's the ladder with the ground. So if I look at what I've been given, in this case I do have my hypotenuse, that's the ladder, and I also have the opposite side. O and H give me sine, so I am going to use sine of X, I don't know what this angle is, equals 23.5 over 25. So I want the angle whose sine is 23.5 over 25. I'm going to use my second function key with sine and then put in 23 divided by 25. And I can round that to the nearest degree, which would be approximately 70 degrees. The other thing you want to check for is you want to make sure that when you turn on your calculator, at the very bottom in the screen it says DEG, which is degrees. If it says something else, typically RAD, then we need to talk about how to change that from radians to degrees. Okay, so other terms you need to be careful of when solving these problems. angle of elevation and angle of depression. The angle of elevation is always inside the triangle, and at the bottom where like the ladder meets the ground or where the person is standing. So the angle of elevation is here, and this is like my triangle. Okay? The angle of depression is outside of the triangle. Now, why would we want to solve something if this is our triangle? Why do I care about this angle? Well, if you look at this, these are parallel lines cut by a transversal, and so the angle of depression is always equal to the angle of elevation. So even though you might have a situation where they say the individual is standing at the top of a tower and someone's standing up here at the top of this tower looking down, this is the horizon and this is their sight line that they're looking down at. That's the angle. But we really don't have to use that. We can use this angle because we know those angles are congruent. Let's see a problem that uses this vocabulary. From the top of a barn 25 feet tall, you see a cat on the ground. Find the angle of depression of the cat. So that wording is sometimes awkward, but I'm looking for the angle of depression if the cat must walk 15 feet to reach the barn. Again, I am going to draw my typical triangle and I'm going to label it out. I'm at the top here looking down at a cat. My angle of depression is technically here, and the barn is 25 feet tall. The cat has to walk 15 feet to reach the barn, and I want to know this angle. Well, this angle is not inside my triangle, but this angle and this angle both measure x. If I find this angle, I also know the angle of depression. When we're looking at this triangle, I do not have the hypotenuse. I have opposite and adjacent. I'm going to write my equation tangent of x. Again, this is opposite over adjacent. Opposite my x is the 25 feet and adjacent to my x is the 15 feet, and I use my inverse function key, second function, tangent, 25 divided by 15, and you should get, this does not tell us what to round to, but it is approximately 59 degrees. We are going to work on a little practice next. So what I would like you to do is go to this page in your practice packet, and we're going to work on the numbers noted at the top. I'm going to solve some of them for you, and we'll go over the others in class. Pause here, and you can work on 1, 2, 8, and 11. Come back and check your answers with me, and then you can work on the others that we will check in class tomorrow. Alrighty, so if you're back with me, I have the answers to 1 and 2 shown. Those should have been relatively straightforward. Let's go down and take a look at number 8. Number 8, typical ladder problem, and we're finding to the nearest degree the angle which the ladder makes with the ground. So in this case we use the cosine function. I did show what the calculator showed here just to give an indication, and then in my last step I rounded, so it was very obvious how I got the 37 degrees. Let's go on and look at number 11. Now the reason I chose this one, you're not finding the missing angle, but I think the wording is very confusing, and you will find some confusing wording on these questions. So you have to keep in mind when we talk about the angle of elevation, it is always that angle that is at the base of whatever your diagram is. Even though it says the angle of elevation of the top of the monument, what that means is if you are standing on the ground, the angle of elevation that you have to look up to the top of the monument, it's really that angle of elevation to the top of the monument, taken at a point 425 feet, is 32. So in this case, I do not have the hypotenuse, so we know it is tangent, and I can just set that up and solve it like we did a couple of days ago. Okay? You can work on the rest of those problems I had listed, and we will go over them tomorrow in class. Have a wonderful evening.